We have 5 or 6 other tools that could be used to model reservoir performance. We have reservoir allocation, material balance, tight gas reservoir, decline curve analysis. But we are going to work with 2, given the data we have, just decline curve analysis and material balance, as we discussed in yesterday's class. So for you to operate on this, you have to choose the tool that you wish to use. That's get to the ribbon where you have to. Then you pick the tool you wish to use, which in this case we are going to use material balance, right? So our first simulation will be to determine the performance of the reservoir and see how we can use this idea to forecast the performance of the reservoir. And you can only do that based on the concept of material balance. And we say, and this material balance works on the principle of history matching. That's why if you get through all this, you are going to see a section where you have history matching, where that's actually the area where we are going to do reservoir or reserve estimation. You see, so I remember asking you guys to research on history matching. Who can remind me what history matching is all about? President, what my attendance is going, you already think like this. Waiting what happened in the past and what is happening now to predict maybe the future of a particular reservoir of interest. What will happen in the future is what we get to match. So that's why you get, when you have this, you have to, please, do you have a piece of chalk? Like model building, right? So that you can actually input what happened in the past to compare what is happening now to predict what may happen in the future. You see, so the first, when you select your tool, you see that the ribbon changes, right? You have so many other options that get there. So for you to start, you have to be a model of the reservoir. That's building a model. You have to choose. So you take option. You take option. By so doing, you are building a model of a reservoir. Are you working with an oil reservoir? Then you take a reservoir, you choose a reservoir fluid to be oil. If not, you go to where you have reservoir fluid and you select the type of fluid you are working with. You see when you click on it, you are going to have other options. You have gas, retrograde condensate, and general. So you can either work with an oil reservoir, a gas reservoir, a condensate reservoir, or general. General means it contains water, oil, and gas. You see? But our interest is to determine the hydrocarbon or the oil initially in place.
So that's what Marshall does.
Is that what in here?
Yes.
To determine the step.
Determine the step and do production prediction. To predict the reservoir performance. So you choose oil. Now, simply, since you are focusing on the reservoir, you choose a tank. You see, so you see the tank model, a single tank, because you are working with just a single reservoir. Had it been we have so many reservoirs within the same piezo, you take multiple tanks, right? But since you are working with a single reservoir, you take a single tank. Now, the model of the pressure, volume, temperature parameters, you also have to determine that, because a PVT model for you to accurately model what is happening within the reservoir, you must know how the pressure, the properties of the fluid varies with pressure, volume, and temperature, right? Yes. So that's why you have to also determine the PVT parameter. Are you just using a simple PVT parameter, or is it changing with time? You see, we assume that these parameters do not change with time. Then we'll use a simple PVT parameter. Since you are working with a reservoir, we'll model the production history by tank. Because if you are working with a well, you model it by well. You see, so you are looking at a scenario where you want to determine the hydrocarbon in place within a reservoir. So you take by tank. Then the compositional model. Generally, you have either you are allowing the software to decide the compositional model for you, that's by taking note, or you wish to determine a single parameter within the whole model, then you take tracking, or you want to determine every detail within the reservoir model you are building, then you take fully compositional. You see, but if you take fully compositional, they are going to take a longer time than normal to run the simulation. So we'll take note. Then here you can fill the information of you, the analyst. Like for example, if you are employed by a company to run the simulation for them, you have to put the company name, the field where you are, then the location of the field, if it's offshore or onshore, the platform, then you as the analyst, your name. So in this area, the company can be named. Anyways, you decide. Then at the end of the day, given that you have to generate reports, right? You have to, I should give you the company name. NAP is the company. Okay, it's slow. But NAP is the company because there's retention in NAP. So it's the company. Yes, you can fill it now. Right. Petroleum engineering is your field. Okay. Then, yes, any field you want to do. Then the user comment, you have to explain, since you are generating a report, right, you have to explain what you intend to do. Are you doing reservoir performance prediction, or are you doing reserve estimation only? So that was the information that you're supposed to put on the user's comment. And you can always turn to edit that information as you run the simulation. Right? That's why MBAL is one of the most user-friendly petroleum software that you can have.
FPSO.
Put anything you like. You can put the Combos platform, no problem, right? Yeah. You can use the LMS platform that I use. Right. So now the next thing is,
Our location is onshore.
when you create a model, right? Once you take option, you select the tool, you already have search, right? The down train there, all in red writings, then you have an empty down. Now you have to create a reservoir model by inputting the PVT parameters.
Done. Finish and take done.
Yes, finish, you take done.
So what are we doing in the comments? What are we doing?
Comment, you are doing reserve estimation and reservoir production prediction. Right. Production prediction.
Wait. Come again.
Have you said? Have you seen my
Reserve and production estimation. Right?
I say you're doing reserve estimation and production prediction. Prediction. Yeah, that's reserve estimation. Right, within the reservoir, because so you click on fluid properties. The reason why you're taking PVT is to model the fluid properties within the reservoir. Remember, when we were doing the theory class yesterday, I said you have to model not just the reservoir, you also have to model the reservoir properties, right? Because if you don't do that accurately, at the end of the day, you might not be able to have good results because most of the time the performance, in fact not most of the times, the performance of the reservoir is mostly dependent on the fluid properties, right? That is why when you check flow based on gases correlation, you must see the integration of the fluid properties within the gases correlation. And when you check at the correlation used to model either transient flow or steady state flow, you see fluid properties integrated in such correlations, right? Because we know that the performance of the reservoir depends on those fluid properties. So you cannot determine either reserve in place or production prediction without modeling the fluid properties. So you have gas oil ratio, gas population, gas oil ratio. Take a value of 290. So I'll take 10,000.
The waters are going to
In fact, take 10,000.
So can take anything above 8,000. 10,000.
Yes. That a fruit is clean, that it doesn't contain any acidic gases in it. Then we'll put 00 all throughout. So please, I'm only telling you some of the assumptions. That's if in your question that you'll be solving, that's you have to run a simulation and then tell you that the fruit is very clean in a way that there are no impurities. It means the percentage of the acidic gases is 0. Let me tell you. In another way, they could tell you that the general percentage for acidic gases is 5%, right? It's 5%. If they say it's 5%, then since nitrogen is always in it always have the lowest percentage. No matter the quantity of nitrogen, since it's in it doesn't have any impact, it always has the lowest percentage. So you assume that the two above to be 0.2, 0.2. Then 2%, then nitrogen 1%. Now, when you do this, you have to actually determine the correlation that best describes the behavior of the fluids. Remember that when we were explaining yesterday, we said when you model the reservoir properties, you have to develop a mathematical model for it, right? Like tell the correlation that best describes the behavior of the fluid. Is it clear? So, hope you guys are seeing that you can understand the lecture of yesterday. So, by how will you do that? You go to March. Now, generally, if you look at this guy, it means you need pressure data, gas oil ratio values for you to calculate, right? But since we don't have, I'll check the oil model they are using there.
Black oil model.
Black oil model. That's why I said you decide, you allow the software to decide. What you think no. Based on the parameters they are inputting, the software automatically picks the model you are supposed to use. Either black oil model or composite model, right? So since you don't have the parameters you put there, you go to calculate. There's a subsection there, calculate. Go to calculate. Are we there?
Take done.
Please take done if you are under. Since we don't have those values, you can calculate. That's why I said at times you might have incomplete data, but embedded in the software, you also have calculation that we use to determine those parameters that are missing. Do we see better than And this actually the imaginary side. You can say you can have data, but that data might be incomplete. But the computer program, which is our software we are looking at, can help us calculate some other parameters which will help to contain the data. Right? Now we are at this stage, the imaginary side. We don't actually know these parameters. And we know that there should be some parameters that will need to complete this simulation. Right? So if you can predict the temperature, if you know the temperature and pressure within this reservoir, then you can use this guy to calculate those other parameters that may be lacking within the data. Right? Now, so when I look at the data set I have, I see that the pressure range between 2,500 to 4,700, right? But if I look closely, I will notice that my bubble point pressure is actually at the point 4,396. You see, so you go to the temperature values. Sorry, I'm not going to give you the data. So the reservoir temperature in degrees Fahrenheit, take 150. Though in one publication in the Rio Basin, they said the reservoir temperature lies between 160 to 166. In most sections of the Rio Basin, 162 to 166. In one of Fozal's publication in 2017, the reservoir temperature was working with was 149.7. So let's take 150. Then take number of steps to be equals to 1. Then the pressure, we said the bubble point pressure we detected there was 3,693. So you take 3,690 psi. So 4,000. So 4,720. Number of iteration that you want. You see, you can decide the number of iteration that you want. If you want it to calculate in 4 steps, 5 steps, 6 steps, but the minimum values that you have to input to have good correlation is actually a minimum of 4. So let's take 6. You can take 10. Are we there? And? No. The temperature 1, then 6. You are modeling within the reservoir. I assume that the reservoir temperature is constant. Any worry? Then you calculate.
You should take click on calculate.
Click. When you look at, let me see something. Calculate, right? You click on calculate. Then, once you click on calculate, you are going to see some data sets calculated, right? But remember, these are not the parameters that we don't need all these parameters. Right? We don't need all these parameters. Are we there? Take down. I was looking at the parameters and the option of saving is not there.
So we have to screenshot these parameters.
Two plus. You need to input gas oil ratio, oil formation volume factor, oil viscosity, gas volume.
So take down to leave from that this thing now.
Yes, take down.
Then we are inputting the take down here.
And then you go now to that mash data. Yeah, in mash. You all those parameters you input them here.
So copy all of this.
Yes.
Everything.
No, not everything. The ones that are needed.
The pressure,
just pressure,
gas oil ratio, formation volume factor,
oil
viscosity,
viscosity,
gas
gas
and
formation, and
gas viscosity.
yes.
Alright.